Hello, welcome. In this video we are going to see how two given functions can be plotted in SAGEMATH, and how can we find the area enclosed, the area between the two curves represented by the functions, and some related operations using these functions. We have the two given functions fx and gx, and these functions can be, first we can define these functions. Fx equal to, okay, we are going to define the function okay, and after that we can define next we can define the second function. So there is okay, some error is there. Okay, and that error is due to the function. It is with that function defined. Error is I think the error is with that f which is used there. So let's replace that f. It is not the correct f typed there. Now you can okay, you can check whether that statement is correct. Yeah, now the statement is correct. Next you can copy the other function. I can see here that the cap is not properly appearing. Okay, then check whether that function, the second function, is also correct. Okay, thus we have defined two functions. Fx and gx are the new functions defined. After that, you can you have various ways of displaying that function. You can use this command show in quotation gx in bracket equal to, and then you can type gx. When you enter, then it will display the function as given here. And that's not a very serious step in our computation, so we are going to skip those steps. And these two steps are not very important, but we are going to plot these two functions because we want to create the graph of the two given functions. So for that you can use for drawing the graph of a function, you can use the plot command or plot function. So plot fx, you can see here, plot then bracket fx comma x between the two x values. If you need the plot between the two x values, then you can give those values. So pi by 4 comma 3 pi by 4 are the lower x value, and the upper x value. You can see that here this is the lower value, and here you have that upper value, the maximum value of x between which the curve is plotted. You can vary that if you want some it in a different interval, in a new different lengthy or smaller interval. You can redefine that values. You can give some different values at these two places, but after giving that values, you have to close that bracket. After that you can again use the same command to plot the second function gx. So plot gx in bracket gx comma x pi by 4 comma 3 pi by 4. Then comma, you can use the color green for that, for plotting this. Okay, for green you can use this. Gx is then plotted in green, but you know this one, the first one will be plotted in default color. So since that color is not specified, but you can specify the color using the same syntax. You can using the same way, same method. You can give a color. You can specify a color for the first function also, but that is not very serious, because automatically the default color will be given to the first function fx. Okay, then when we implement this this command, this line, when we run when we apply this line, then the system will generate the plot of the two functions. The curve of the two functions will be generated, so that you can test by copying the entire line, by copying the entire line and then pasting it in a new input box. But you have to correct, you have to check whether all the characters are properly appearing there. So f of plot fx, you have to check whether this f is correct, and fx and x, then pi by 4, 3. Okay, there, what is that? 3 pi by 4 actually, but it is not appearing there. First one is pi by 4, and but the other one is 3 pi by 4, 3 star pi by 4. So there was an we have detected an error. Then bracket is closed. Okay, and the bracket is closed. After that you have to use plus, then plot. After that a bracket, starts a bracket, then g of x, gx comma plot g of x, then x comma x, and pi by 4, and 3 into pi by 3 into pi by 4, 3 into pi divided by 4. Okay, pi by 4 and 3 pi by 4, after that we have that color, pi by 4 comma color, COLOR is the spelling. COLOR, color equals that quotation must also be correct. The right quotation must be there. Yeah, we will type it again, because there's a chance of wrong or mistake of there's a chance of spelling mistake there. So green. Okay, now we have that completed completed expression, completed command, and you can check whether it is correct, whether you are going to get the output. Yeah, there was no error in that type setting, and so we have obtained that curve. Okay, After obtaining the curve, and so this is the command that generates that curve. And after obtaining the curve, you can now, in a different way, you can approach this problem. That is, we are going to be going to reduce the size of that figure. You can see here the size. It appears here with the default size. So the size is actually determined by the system. But if you want to reduce it for getting good appearance, or for something else, if you want to reduce or change the size of this figure, you can do that using using the, or including the command part, including the part of the command figure size. You can use figure size inside that command. You can specify the figure size equal to 3. Here it is specified as 3 figure size. So for that, once again you can, because fx and gx are already defined there, so it is still it is continuing that functions are there stored in the location of fx and gx, so you can use it repeatedly. You can use it. So in this step, but what we are doing is we are defining a new function, a new variable. We are defining a new variable h, and to that variable we are assigning the plot of the functions fx and gx. By considering both functions together, you can plot. So this is a different approach to the same problem, or the similar problem. Okay. The problem is that simultaneously we want the curves of the functions in one figure. So we want these two curves together. So that effect can be produced using another a slightly different command. For that, we type h equal to plot. Then in bracket you can type you can use fx and gx, both functions, and then comma, you can type x. After that you can specify in the lower x value, and then you can specify the upper x value. After that, by separating it by comma, you can specify the figure size. That figure size is here equal to 3, and then comma, fill equal to true. So here in this step we are going to fill the region under the curve using some default color, so that the color with which the figure, the area under the figure is to be filled will be decided by the system. So for that, for verifying that, we can copy that command. So before that, you should carefully go through each part of that command. Okay, now you can copy it, and you have to check whether all symbols and everything have been copied correctly. H equal to plot of fx, that f must be correctly must be correct. It must be corrected, f of x, and then comma gx. Okay, that part is now complete. Then comma x, then pi by 4, comma 3 into pi by 4. Okay, that's correct. Then figure size equal to 3. Okay, then fill equal to true. Once again check it, compare it with that original command part after the. Okay, now it is verified. It seems that it is correct. Now you can take the output by using alt enter command. Wait for that output. It will come only slowly. It will either show an error or it will give you the output. Oh no, this much time is we won't take, because there is some more is to be done to obtain that output, because here by implementing this line you are storing that graph of the curves fx and gx at the location of h. So if you want to take that, if you want to display the content of that location, content of the location of h, you have to apply, you have to use the command either show h or just h. You can use. So show h, you have to use the command, additional command show h to display that. Okay, yeah, you can see in that figure you have that output. This output, you have obtained that output. So you should note the necessary things to be included in the command part to obtain this output. Okay, next we can use these two functions to calculate the area between the two curves. In this in this example, we the following example, or in the discussion, that in the foregoing discussion, we will learn how to use two functions, or how to calculate the area between the two curves. Here we are considering, we are taking the two curves related to gx and fx. Gx and fx. See, gx, here one curve is fx and the other curve is gx. So you can see, and this is the area enclosed between the curves, which is now available in here. You can see the shaded region in green color. In green color, green colored area region is the area that we are going to calculate. So for that, you can define a new variable. A is equal to, A stands for area. A equal to integral. You know that formula. You can apply the integration method. Integration using that integral. You can use the function. One function can be subtracted from the other in order to get the area between the two curves. So one curve can be subtracted from the other, and after that you can integrate it with respect to x, and then apply, you have to apply the lower and upper limit of limit with respect to x, or the lower and upper x values you can apply. Thus you can applying that values inside that integral, indifferent integral, you can find the value, exact value of the integral. So that for that you can write it, a is equal to integral of gx minus fx, gx minus fx, then comma x from pi by 4 to 3 pi by 4. After that you can take the output using the command show a. Okay, a equal to integral then gx minus fx comma x pi by 4 3 pi by 4. Okay, we apply that, we implement that command. Then you have to display the content. Now it is that value has been calculated, and it is now stored in the location of a. So you can use show a command to show a to take that output. Okay, nicely it is it's available here, that value, and that is value of the area. Value means the area between the two curves is minus 1 by 2 into root 2 plus 2. Okay, and this is the method to that can be applied to calculate the area between two curves. You have to subtract one curve from the other curve, and then integrate it between the given limits of x. Okay. And here two more functions are given. Now you can you are asked to plot the curves of two given functions. Fx equal to, these functions are new functions. Fx equal to 2 into x into x square minus 4 x plus 2, x square minus 4x plus 2, and then the second function is gx equal to x square. Using these two functions, you have to plot the both curves between the limits between the values x equal to minus 1. You have to plot these two curves between x equal to minus 1 and x equal to 6, and you have to specify the size, figure size as equal to 5, and also by using between the two y values, the curve, the figure, it is decided that the figure, the region of the figure must range from y equal to minus 20. Here you have that y equal to minus 20. Between the y value, y minimum is minus 20 and y maximum is equal to 20. So here you have that maximum value 20, but y minimum, it is not correctly satisfied here, because y minimum, you can see it you're almost starting at the value minus 15. If that curve does not go beyond that limit, then it will be displayed as shown here, but it is there's a chance that this curve can go further in the lower downwards in this direction, but that may be a mistake in the figure. So we can check that whether we are going to get the same curve, same figure exactly. Okay, for that we copy that function okay. We can now copy that function. For that we are going to copy the function and paste it. F of x equal to 2 into x into x cap 2 minus 4 into x plus 2, and gx equal to next we use that plot function, plot command. Plot fx comma gx, then x and x comma minus 1 minus 1 6 comma minus 1 6 6, and figure size fig size, fixed size equal to 5. Fig size equals 5 comma y min minus 20 y max y min equals minus 20 and y mix equals 20. The 5G SI is a fixed size. You have to check if 5G SI is a okay. You have to check each part of the command for before applying before taking that output. Okay, we have got that. We have got the figure. We have got the output. So you can analyze that command, that plot. The plot command. You can analyze each part of that plot command to learn more about the structure. Okay, this plot, then in bracket fx, again bracket fx comma gx, bracket closed. After that you can type x, and then x limits minus 1 to 6, minus 1 to to 6, and then figure size is 5 specified, and also we can give the lower value, the minimum value of y, and the maximum value of minimum value of y and maximum value of y. Okay, that's all about different applications of plot function, and we have also seen how to determine the area between two curves, and we have seen simultaneously how to draw simultaneously the two curves in one figure, and these are the areas that we discussed. Okay, thank you.